Welcome back to Database History. Today, we're diving into a database engine that's, well, small but seriously mighty. It's called the Lightning Memory Mapped Database, or LMDB for short, and its story is all about how keeping things incredibly simple can unlock some absolutely mind-blowing performance.
So let's just start with this one. Really powerful question. What if a database had zero overhead? Seriously, think about that. No complicated caching layers, no copying data all over the place, just you and your information, direct access. This isn't just a hypothetical, you know? That exact question is the beating heart of LMDB's design, and it's the real secret sauce behind its speed.
All right, so where does an idea this radical even come from? Well, like a lot of the best inventions, LMDB wasn't dreamt up in some fancy boardroom. Nope, it was born out of a real-world problem, a desperate need for some serious speed.
Let's go back in time a bit. The year is 2011. You've got Howard Chu, a super sharp developer on the OpenLDAP project, and he's just hitting a wall. The database they were using, BerkeleyDB, a real classic, was just choking under heavy read loads. He needed something faster, simpler, way more predictable. So what's a guy to do? Well, he built it himself. And the result? LMDB, a database engineered from day one to be an absolute beast at one thing, reading data.
Okay, so this is where we get into the really cool stuff, the how. That name, Lightning, isn't just some slick marketing term. It's the real deal, and it comes from a truly clever and super efficient architecture. So let's pop the hood and see what makes this thing so fast.
The magic really starts with something called memory mapped files. Now, usually your app has to constantly bug the operating system. Like, hey, can you read this little piece of the file for me? Now this piece. With memory mapping, the OS just goes, you know what? Here. It maps the entire database file right into your app's memory. It's basically like handing your application a VIP pass to the data warehouse. No waiting in line, no security checks, no overhead from those system calls. And that right there is the zero-copy advantage. Since the data is already mapped, you don't have to make any extra copies. Your app isn't shuffling data from the operating system's buffers over to its own buffers. It just reads it directly. What used to be a whole process becomes a simple, lightning-fast pointer lookup. And that, my friends, is the core of LMDB's speed. It's just elegant.
But look, speed is great and all, but if your data gets corrupted, it's useless, right? Well, you don't have to worry about that here. LMDB is built like a fortress. It's fully ACID compliant, which is the gold standard for making sure your transactions are rock solid. And get this, it's basically crash-proof by its very design. The database file on the disk is always in a consistent state. It's perfectly tuned for what it's meant to do. Handle tons of reads at the same time, super fast, while making sure the writes happen one at a time to keep everything perfectly in sync.
All right, so we've got this minimalist powerhouse, but how does it actually stack up against some of the other big names out there? Because let's be real, every technology has its trade-offs. It's time for a little clash of the databases to see where LMDB really shines. Okay, when you lay it all out like this, you can really see where LMDB carves out its niche. Against its ancestor, BerkeleyDB, it's just cleaner, leaner, more predictable. But the really interesting comparison is with databases like LevelDB or RocksDB. Now, those guys are built on something called a log-structured merge tree, and they are absolute chance for write-heavy stuff. But there's a catch. They need a lot of tuning and constant background work called compaction to keep reads fast. LMDB? Nope. You get that insane predictable read speed from the get-go. The trade-off? It's designed for a single writer at a time, so it's not the best choice if you're writing data constantly from many different places.
So you've got this special mix, speed, simplicity, reliability, and you better believe people have noticed. This isn't just some cool idea on a whiteboard. Let's talk about where this thing is actually being put to work in the real world.
Yeah, LMDB is kind of like the silent workhorse behind some incredibly important systems. Of course, it's still at the heart of OpenLDAP. That's where it started. But you'll also find it powering high-speed AI frameworks, tucked away deep inside operating system kernels, and even securing cryptocurrency wallets. Think about that. Places where speed and knowing your data is safe are just absolutely critical.
But the impact of LMDB goes way beyond just the projects it's used in. The whole philosophy behind it, that obsession with simplicity, efficiency, and rock-solid reliability, has created this lasting legacy in the open-source world. It's really made a lot of developers stop and think differently about how databases can be designed.
And this quote, this just nails it. It's become a huge favorite for a certain kind of developer. We're talking about the systems engineers, the embedded developers, the folks who are really down in the weeds, who live and breathe raw efficiency and absolutely demand stability. They get it, they love it.
So when you look at its legacy, what do you see? It's a testament to the idea that sometimes the most elegant solution is the simplest one. It's open source, its stability is proven over and over, and it's driven by a passionate community. LMDB is the perfect example of a tool that does one thing: blazing fast, reliable reads, and just knocks it out of the park.
And that really brings us to our final question for you. We live in an age where software just keeps getting more and more complex, right? LMDB is this powerful argument for the other direction. It really makes you think, in our race for more features and more complexity, have we forgotten that sometimes radical simplicity is the biggest performance boost of all?